because we only got about 1 minute and 45 seconds to go. And I am going to download my document. And it's already pinned in today's lecture as well, so if you missed that from the previous lecture, you can just go ahead and use the pinned attachment from today's lecture. And I really encourage that you guys have your own open on your side, so this way, when I scroll like crazy, you're not going to get disoriented, and you can keep focusing on a specific point that you want to kind of keep your attention on, while I'm kind of jumping around and talking about other things. So please go ahead and download your own version and have it opened in your own browser. I think that will be effective. It's not required. Obviously, I cannot really tell what you guys are doing on the other side, but I think that would be more efficient from the perspective of going through the material. Alrighty. And we got half a minute. Oh, right. I kind of need to get my editor up and running as well, because that's how I'm going to be typing the answers. So let me put it on the side, just outside of your view. So that's going to be, yeah, go ahead. All right, so unless you're planning to ask questions using the voice channel, please remember to mute yourself on Discord. Thank you. Or if you have one of those, hardware switch, on your mic, that works too. I got one of those, on mine, and it's really handy, because I don't have to reach for a particular key on the keyboard or have to navigate to a button in order to do that. All right, so it is time to get started. So let's go ahead and get started here. This is the exact exam from last semester, so it's from fall 2021, and and for the first time last semester, for the very first time, I was reusing the same questions from a prior semester. So this was actually also the kind of question that I asked in the summer session of 2021. So I was doing the experiment to see if it makes any difference, like in terms of the performance of the class as a whole, and interestingly, I did not observe a whole lot of difference. That really kind of surprised me, because I was thinking if people have like a whole week to look at these questions and kind of get used to the methods of answering these questions, it probably would make some difference. Nope, that did not make a difference. And then later on, I found out that most people did not actually spend the time to review the content of this exam, and they just thought, okay, I listened to what Dr. Tech has to say, I seem to understand what he's saying during class, I should be good for the exam. Okay, I don't need to go over this again by myself. Some people did that, and that did not turn out very well. And the people who actually went in and actually did everything, did all 16 questions back and forth, those people tend to be the ones who would not have a problem to begin with. So there's that. I wouldn't say they're lazy. I try not to judge people, but the fact is they may not be spending enough time. So they may have other commitment, because of family, because of the pandemic, because of work. There can be a lot of reasons why people may not be able to spend the time that I think is necessary in on this class. But in order to succeed in a class like this, spending enough time is really crucial. So so I'm gonna just leave it at that. All right, so let's go ahead and get started right away, because I really don't want to waste too much time. So I'm going to start with the last question. Remember what I said, if this is the first time you see questions like this, it might be helpful to build your confidence to start with the last 8 questions because they are easier compared to the next 5, and then those 5 are easier than the first 3. So the first 3 questions are the hardest. I forgot. Sorry about this. All the scrolling. I do not. There we go. Okay, so I do want to kind of mention, how this worked last semester. Now remember, there's no guarantee what your questions may look like. Okay, so do not think that Tech is going to do this again. He's going to use the same questions from last semester. So do not make that assumption. Yeah, do not make that assumption. That's all I'm going to say. All right, so I'm going to go through the steps and the instructions, and it's really important to go through the instructions. Even if you think you probably know what is in the instructions, go through that anyway, okay? Because if you missed a description or if you missed one part of the instruction, it may have a significant impact on your grade. So do not make assumptions. All right, so obviously the date and the time, will both be changed because um, just because it's not the same schedule as last semester. Discord channels will be disabled. Direct message me if you need clarifications. If I do notice anything that is wrong or can be improved in the exam, I will use announcement in Canvas to notify everybody. But if you want to contact me, if you want to initiate a conversation with me during the exam, use Discord and direct message me. That would be the easiest way. If you want to use email, that works too, but email is not going to be as interactive. So there is that. This document is only for the individual with an ID of W0006887. So everybody would get that person's own exam questions. I'm not going to answer the questions of, but are they going to be the same between people or are they going to be different between people? I'm not going to answer that question because it really should not be important to you guys, right? It is important to me because it means more work if I have like 20 bazillion questions and everybody has a different set of questions. But to each individual who is taking the test, that really should not make a difference. So here we go. This exam is an individual exam. No collaboration is permitted. Online and offline resources can be used as long as there's no interaction or collaboration involved. So use your best judgment, okay, to interpret what is considered collaboration. For instance, if somebody wrote a Wikipedia page on the concept of borrowing in subtraction, and that was done like 20 years ago. Well, okay, cannot be 20 years ago because Wikipedia may not have existed for 20 years. So let's just say that was done like 5 years ago. Okay, that would not be counted as collaboration for many reasons. Okay, because it is not this event. Okay, the exam definitely is outside of that time frame. Two, there's no interaction between the person taking the test, looking up Wikipedia, and the person who actually authored that page on Wikipedia. Oh, 21 years. Okay, thank you, Omir. But the point still stands that would not count as collaboration. On the other hand, if somebody posts on Quora or post whatever question I give you guys on what is the other one? Reddit. That's it. Expecting somebody to be able to get back to them during that time frame, the time frame of the exam, that would count as collaboration. Okay. Now, what if nobody actually responded, right? Okay, someone just said, okay, this is my exam question. I want somebody to help me with these questions. What if no one actually responded? I would still count it as cheating. I would still count it as cheating because it is an attempt to show possession of knowledge or a level of skill that is beyond the person who's taking the test. Okay, so just the attempt part is already qualifying. Okay, even if nobody responded, because people look at those questions and go like, no one asked questions like this. Okay, I'm not going to help you with that. Okay. Do not share or discuss any part of this exam with anyone in class or otherwise on the day of the exam. So this is helping to explain to people what is considered collaboration. Grading is based on explanation in steps, demonstration of understanding of knowledge, and problem solving skills, not the final answer. So that means if somebody just gives me the final answer with no explanations whatsoever when the question itself asks for explanation, that answer may not worth a lot of points, if any. Write your answers in this document right after each question. That still applies to your exam. So don't write it on a piece of paper and then take a picture of that and then paste it into the document. I know it can be done. I just don't want it to be done. Okay, so yeah, all your answers should be typed, not written. I should change that to type, not write. Do all your text editing in document. Do not copy and paste from an outside source. It is okay to copy and paste from within the document itself. So if you say, oh, this part of the answer is kind of applicable everywhere, so you can just go ahead and copy and paste it, as applicable. Not a problem. You can copy and paste non-text content such as images and cells from a spreadsheet, for example. I think I'm gonna take this sentence out. If we use scrap paper, should we turn it in as well? Nope, you do not have to turn in scrap paper. Everything, all the evidence of you knowing your stuff in this class should be typed as a part of the Google document. So if you need to work on something on the side, you don't have to turn it in, but whatever you turn in is what I'm going to use to grade your exam, to assess how much you know and whether you can apply the knowledge that you have gained in this class. Here are the groups of questions. So this is applicable only to this exam. So your exam can be structured differently. So group A consists of Q1 to Q3, question 1 to question 3. Group B consists of question 4 to question 8, and then group C consists of question 9, to question 16. So I also specify, how many known bits are in each question for each group. So in group A, there are only 4 known bits, okay, of the entire question. The next group has 6, and then the last group has 8 known bits. So as you probably can imagine, the more known bits there are, the easier it is to figure out the rest of the bits. But there is one caveat with Group C, because in Group C, if somebody gets all 8 questions, the best grade that person can get is a letter grade of B and not an A, because those are easier questions. So, for last semester and also for summer session, I let people decide, right? Because okay, if you think you can get the first 3 questions, so be it. Okay, that will be fewer questions, but each question is going to be a little bit harder. And then the next 5 questions are a little bit easier compared to the first 3, but there are more in terms of quantity of those questions. So I got a question in the text channel. So the point is not to do all the questions, it is to choose which group to do. Honestly, I let everybody to make up their own mind. Okay, so I'm not going to recommend anything, except in this case, let me know which. Only one group needs to be answered. So if someone decides to answer all 3 groups, I'm not going to say you cannot do it. You certainly can do it. Just tell me which one you want me to use for grading purposes. If that is not indicated, I'm going to use the first group that has answers. So I think I put that in as well, like right there. Okay, I will use the first group that has any answer if there's no indication which group I should be using for grading purposes. But remember, this is from last semester. This semester can be entirely different, so read the instructions carefully. And this is one of the things where it can be considered controversial. At least one student got into a good discussion with me last semester, which is, Tech, you should be teaching to the exam. And I said, no, I don't do that. And then there was a long discussion, and um, I'm not gonna bore you guys with the details of that discussion, but just keep in mind that I do not teach you guys um, to succeed in a specific type of exam. Okay, so do not make the assumption that this is going to be the same format as what you will encounter. All right. So with that all said, unless there are questions, I am going to start with the very last question, and then we'll work our way back up. So chances are we may not have enough time to actually do all of the questions. So I might just kind of do one from the last group C, and then one from group B, and then one from group A, and then see what other questions you guys might have. All right, so this is question 16 of 16, and we need to figure out, what each bit is, wherever there's a question mark. And let me kind of zoom in a little bit more. And then what I'll do is I am peeling off my own notes. So this way I can overlay what I type here on, right next to what you are already seeing as a part of the question. All right, so I'm going to overlap as much as I can without losing the content on the other side, like right there. Okay, that's good. All right, so this is question 16. And we'll go ahead. All right, so there's a lot of bits are unknown, so we want to figure out, where am I going to start, right? Where am I going to start? So when you approach this kind of question, the first thing you need to do is to remember what the definitions are. Okay, how are the q bits related to the x and the y bits? How are the t bits related to the x, y, q, and t of a previous column? And how the d bits are related to the q and the t bits. Okay, so you got to have all of that, all of those definitions, if not memorized, at least at your fingertip. Okay, so I have been saying this since the beginning of the semester. I know I am a broken record. Okay, keep all your definitions and the symbol definitions together. Okay, because that's going to help you look things up. So the way I expect the answer, in terms of to explain that that your stuff and you know how to apply it, is you have to first figure out what definition am I going to use. So I'm going to start with, let's see, Q2 looks like a good one to start with. So let's go ahead and get started with Q2. One more thing, when you are answering the questions, don't bother with the square brackets or the subscripting, because that's just going to take you extra time. Okay, so don't do anything that will take you extra time that is not necessary. I can read Q2 just as fine, and I would understand it as bit 2 of the Q row. Okay, so no need to use a subscript or using the square brackets around the 2. But instead of doing this, I'm going to quote the actual general equation, which is Qi is xi exclusive OR with yi. So once again, if you don't know how to type in the exclusive OR symbol, you can just spell it out as XOR for exclusive OR. So in this case, I'm quoting the rule, and as a result, so Q2 equals to x2 exclusive OR with y2, which in this case I know what those two bits are already, because x2 is a 1 and then y2 is a 0, and that means we have a 1 for Q2. All right, so this is important. Okay, you have to kind of let me know where you start, how you get started with it, how it applies to this particular bit, and what is the actual answer to this particular bit. So those are the 3 components that I will be looking for. Are we supposed to replace the question marks with the digits as well? It would be helpful to do it, because then you can actually see how the whole thing progresses. So yes, so if you so make a copy of that first. So in the actual exam, this is going to be a Google Doc. So that means, if you are asked the same kind of questions. Okay, so if you're asked the same kind of questions, you can just do this. Select just this portion, Control C, and then somewhere else, right next to your answer, do a Control V. So that way, you can always refer back to the original question with all the question marks, and also fill in those bits, on your own. So to do that, over here, I can do about the same thing. It's not going to be easy because I need to, I think 4 spaces is what I need to start basically literal stuff here. I'm not, nope, it doesn't do that. Let me put in, there we go. Yeah, I just have to have enough, leading spaces to do this, or I can just use the backtick. Backtick doesn't work as well because it is it's gonna put in some syntax highlighting. I'm pretty sure there's a way not to actually put in the syntax highlighting, but I cannot remember how to do that. All right, so I'm just gonna do this. This is gonna be, it's gonna take a little bit of time. It doesn't understand that is also related to the previous column. I just need more spaces. Nope, still not recognizing it. Oh, now it works. Okay, so let's get back to the text channel. So what do you think about if we find Q2, since D2 is Q2 exclusive OR with TX equals to 0 equals to X2 exclusive OR with 1? Well, you can do it that way too. Okay, so I can show you. You can certainly do it that way, because you can say that Q2 exclusive OR with 1 equals to 0, and based on the exclusive OR, Q2 has to be a 1. So that is also another way to answer this part of the question. But I am just gonna format the answer. I'm just putting in extra spaces to make it look nice. All right, so at this point we know this is going to be a 1, and then this is a 0. This is still unknown. And then we have the overall borrow bit, 1, 1, and then a question mark, and then another bar over here, and then we have 0. Oops. Yeah, this is just going to take me some extra time to type. It's not a big deal. Overflow is unknown. L is also unknown at this point. There we go. All right. So so the first point here, the first bullet point, is already answering the question that Q2 is a 1. So that's why we put a 1 into the position of Q2. So at this point we can also answer the question of what is T3. So basically you are just going to be scanning through the known bits, and then you're asking, okay, so what is the next one that I can work on? Now there can be multiple ones that you can work on at the same time. That's entirely possible. Just pick one, okay? However, if somebody shows me the reasoning of how the bits are figured out, but it is in the wrong order, I will take points off. Okay, and that's going to be like it will bump the answer or the grade for that particular portion significantly down, because if somebody shows me the right answer but the ordering is wrong, that shows me that person may not actually be understanding the concept correctly. So the ordering is important. So right now I think T3 can be figured out. So instead of saying it's just T3 equals to something, I'm just going to say Ti plus 1. So this time I'm going to use bracket, just because otherwise if I just say Ti plus 1, it can be interpreted as T of I or 1, which is not the intention. So now this one is going to be and you can expand the borrow function too. So if you want to put in just using the borrow function, that's fine. If you want to expand the borrow function using negation, logical negation, and conjunction, that's fine as well. So this is qi or qiti right there. So in this case, we have t3, which is b of x2, y2, or b of q2, t2. And all of those bits are known already. Let me go back to here. So we have 1 minus 0, which does not have a borrow, 1 minus 1, which also does not have a borrow. So the overall value of t3 is going to be a 0. So now we can go back into the kind of matrix here and kind of put a 0 over here. Alright, so now we can move on to the next item. Who's going to be next? So just to respond to what Bilal said a little bit earlier, let's try to figure out this y1 over here. So to answer that portion, so this is why it's helpful to have these definitions here, and you can even designate. Okay, when I went over this with the class, you can say this is definition A. So now, instead of just quoting the entire equation, you can say, definition A, and this time you're saying x1. Oh, excuse me. So you're saying, q1 is x1 exclusive OR with y1, and that turns out to be a 1. So it's a 0. So q1 is a 0. And we also know that it is 0 exclusive OR with y1. 0 exclusive OR with y1. And you can also now say it implies that y1 equals to 0. So that would complete the chain of reasoning. You start with a definition, and in this case it is just a reference to something that you have already defined up here, so that would save you some typing. And then you make use of the bits that you have figured out so far, and also state the relationship between the bits, and then resolve the ones that you already know, and using that you can now infer that y1 equals to 0. Alright, so Bilal said, oh, okay, that's not new, or is it? Oh, that's not new? Okay, alright. Okay. Alright, cool. Alright, so now where are we gonna where do we move on to at this point? Oh, that's a 0. Let's move on to the fun column. Okay, the fun column is column 0 because it has a whole bunch of question marks. This one here, the D1, is actually pretty easy to figure out, so we might as well just kind of do it. So we can say this is definition C, and you can reference the definitions across questions too, or across answers, so that way you can basically reuse the definition in some of your other answers if that's what you want to do. Alright, so we say DI is QI exclusive OR with TI, and for this particular spot we have D1, which is supposed to be Q1 exclusive OR with T1, but we already know the values of Q1 and T1. One is a 0, the other one is a 1, and the exclusive OR between the values of 0 and 1 is 1. So now we figure out what T1 is supposed to be. Oh, no, I misspoke. Now we figure out what is D1. D1 is supposed to be a 1 over here. So now we just fill in this extra one here. That's an easy one. Alright, so now we're going to take a look at column 0. So column 0 is a little bit interesting because you might look at this and go like, oh, how are we going to figure this out? Well, since I gave you guys this particular exercise from the previous class on Tuesday, and I did emphasize that even though there was no lab on Tuesday, I would like you guys to work on this using the lab time. So I am going to assume that some of you have actually spent the time, hopefully all of you, but I will settle for some, not all. So how do we approach this at this point? I know some of you may intuitively know what the answer is, but how do you explain it? What is the chain of reasoning you can use? Nope, T0 cannot be implied to be 0. So there's no implication that T0 has to be 0 in these questions. T0 is just like any other bits. Okay, if it's a question mark, it can be a 0 or a 1. Look at T1. Okay, very good. Okay, I like Vincent's idea. So let's start with that. Okay, so we start with a definition, another definition. Actually, we have one already here. That's why I jumped from definition A to definition C, because this is our definition B for borrow. Wow, okay, imagine that. All right, so we now say, okay, we have definition B. So the question is, how are we going to make use of definition B? All right, Chris said, solve y1 next. Y1 is already done. You mean y0? Oh, right. Well, y0 cannot be solved. It cannot be solved yet. Okay, we cannot determine whether this has to be a 1 or a 0 by itself. Using just the local context, there's no way you can determine that. So we do know that T1 is a 1. So what do we do next? We expand it. Okay, once you know a bit is already known to be a certain value, we expand the equation so that we can say, okay, how can we make it a 1? So now we say T1 is a 1, but using definition B, it is supposed to be B of x0, y0, or B of q0, t0. And then we expand it a little bit more, right? So we expand it a little bit more, and then we say, what is B of something, right? B of something is just exactly what Vincent has put into the text channel here. So now it is the negation of, and if you want to use another definition, that's fine too. So we can say, definition D is basically saying B of xy is not x and y. So using that, I can now expand everything using logical operations. So we have not x0 and y0, and also we need one more, maybe not one more, because we have the q bits already explained. So I can quote that one over here as well. So using definition A and definition B, and also definition D from before. Okay. So now I can say, what is Q? Q is really just the exclusive OR between x and 0 and y0. So this is just the exclusive OR between those two. But Q has to be negated first before it is ANDed with T0. And that turns out to be a 1. Okay? All right. So it probably helps to open the subpoint to do this part here, because I'm going to do some derivation, so I can copy and paste the lines in between those. So are we doing okay so far with this line here? Because this is an important step. Okay, I am quoting the correct definitions that are needed in order to fill in this line. I know T1 is a 1 already, because okay, I see the I just lost the table because of the extra indentation. All right, fine. All right, so because I know T1 is a 1 already, so now I can use that, okay, and say, okay, this cumbersome long expression here is going to end up with a 1 because that 1 is given to me. I also know one extra thing, which is x0 here. So now I can now say, knowing that x0 is a 1, then we can kind of quote the same equation here. So I'm going to paste it and then get rid of that line like so. So every place we can see x0, we just replace it with a 1. Oh, that's a comma. Let's see. So now we have this one. This is a 1. And also this is a 1. All right. So what is that buying me? I mean, how is this helpful? How is the substitution being helpful in this case? So now I look at this, okay, and I don't need the references using the B functions anymore, because I can now just kind of focus on this part of the equation. So now we can see, oh, not 1 is just 0. Okay, so not 1 is just 0 here. And then we have one exclusive OR with y t0 equals to 1. So one thing we know for sure is 0 and y0. It doesn't matter what y0 is. 0 and whatever is 0. Okay, so we can kind of do the simplification. So we can now say this whole thing is just 0 itself. But 0 or false or whatever is just the whatever. So now we are only left with that part. So that means we have now we have finally gotten to the point where we can say this entire thing is going to be a 1. So it does give us one direct answer right away, because in order for the result of a conjunction to be a 1, all components of the conjunction must be 1s. So this implies t0 is a 1 right away. So t0 is now resolved. Okay, I can go back to the picture and put a 1 where t0 is supposed to be. But on top of that, we also know that this expression here is also going to be a 1, because otherwise, the overall conjunction cannot be giving me a 1. So now we can also say, and the negation of 1 exclusive OR with y0 is a 1 as well. So now the question is, how is that going to help me, right? The negation of 1 exclusive OR with y0 is a 1 implies 1 exclusive OR with y0 is a 0. Does that make sense? Because if the negation of something is a 1, then the non-negative version of that thing has to be a 0. So now, what is that going to buy me? So now I can say 1 exclusive OR with y0 is a 0. And I'm going to let you guys help me out here. So what is the next step? How can I determine what y0 is? Y0 has to be, come on, exclusive OR is kind of like different. Exactly. So now we can know that y0 is indeed a 1. And now we can go back to the Q definition using definition A. Q0 is x0 exclusive OR with y0, and that it is 1 exclusive OR with 1, and that is just 0. So now we can go back and backfill Q0 to be a 0. And then D is the exclusive OR between the Q and the T. So at this point, I'm no longer typing. I'm just kind of reasoning it out using voice. You cannot do this in your exam, okay? But for the because when I'm explaining, it does take more time because I have to verbalize everything instead of just typing it out. So D is going to be a 1. Just because okay, fine, I'm going to type it out. Alright, so where is the definition of D? It is definition C. So D0 is Q0 exclusive OR with T0, which in this case is 0 exclusive OR with 1, which is a 1. Alright, so we still have overflow and L to work with. Overflow has its own equation, so you kind of have to spell it out. So this is another definition, so it's going to be definition E. Overflow is, in this case, we have a 3-bit subtraction, so it's going to be the negation of x2 y2 d2, or x2 not y2 not d2. And since we already know the values of all of those bits, it becomes not 1 and 0 and 0, or 1 and not 0 and not 0. So that turns out to be just 1. So now we can backfill overflow to be a 1. And then we need one more definition, which is definition F. The L flag is the exclusive OR between the sign flag and the overflow flag. Now we know everything. By the way, the sign flag is nothing more than just D2 in this case, the most significant bit of the difference. So now we have all the bits already. So this becomes 0 exclusive OR with 0, which is 0. So L flag is a 0 here. All right, so do we have any questions about how I answer this question? It is all step by step. We start with the definition, we start with things that are known, and then we apply some reasoning, plug in some known values in order to figure out the unknown bit. But the ordering is important. It seems crazy to me that you had two unknowns, but you were able to figure out both. Usually in math you can only have one unknown. Wow, this is the magical Boolean algebra world. It's just like Sudoku, right? I mean, you have some unknowns, but then the constraints will help you figure out what those values can be. Can you go over T0 one more time? Overflow is a 1 does not automatically imply L is 1, because L, it depends on the definition, right? Because L, that's why this is why I need you to quote me the definition of the bits, okay? Because if L is the exclusive OR between the most significant bit of the difference and the overflow flag, that's how it's defined. You cannot just say that if I know overflow is a 1, then L has to be a 1. Well, sometimes it is. It depends on whether D2 is a 1 or not. Oh, I see what you mean. I got it wrong. Yep, that's a 0. This is a 1. Yep. Okay, you got it. I misunderstood, Cole. Yeah, so I got it wrong. Because I misread my own thing, my own answer. Alright, so I misread my own answer because I wrote here overflow is a 1, but then I put in a 0, in place of that 1. So I have to fix that. It is a 1, so that's why it is a 1. So thank you, Cole, for correcting my mistake. Alright, so there you go. Excellent. Alright. And obviously down here has to be changed too. So that's a 1 over here. Alright. Okay, so let me see if I have missed any questions in the text channel. Right, T0. Okay, so T0 is figured out. Now, the nice thing about using a web page or something like that is I can just search for T0. So right here, okay, so the first mention of T0 is right here. Alright, so let's see if we can kind of follow this line of reasoning. T1 equals to 1. Okay, so let me kind of scroll down a little bit here. So T1 is a 1 is given because we got this bit already figured out by the time we got to this point of the reasoning. This part here is really just the definition of T1 using the general equation of T of I plus 1. That's how we derive this part here. And then this part here is based on how the b function is defined. The b function b of xy is not x and y. So we just kind of expanded the b function so that we end up with only logical operators. And then from here to here, we already know x0 is a 1 because by the time we got there, x0 is a 1 already. In fact, in the question, x0 is already known to be a 1. So we substituted. So that's all we did. It was to substitute everywhere we see x0, we substitute with a value, an actual constant of 1. Everywhere we see x0, we change it to a 1, and then everywhere we see x0, we change it to a 1. And then from here to here, okay, so now we just kind of simplify, because all we did was to look at, not 1 is a 0. That's how we end up with this 0 here. And this 1 here is not negated, so it has to be maintained as 1 itself. So that's from here to here is really just one simplification of not 1 is a 0. And then from here to here, um, we simplified out this thing here, because false and whatever is always false, and then false or whatever is just whatever. So I basically did two simplifications in a row to end up with to simplify the whole thing to just this portion here. So with just this portion, it is still a conjunction, okay? Because this negation only applies to one exclusive OR with y0, and then we have a conjunction to with t0. So when you have a conjunction and the result of the conjunction is true, then you need all components of the conjunction to be true, and that's why we have t0 has to be a 1. But we also know the other expression, which is a little bit more complex, also has to be a 1. Now, this expression here is a logically negated expression, which means the non-negative version has to be a false, right? So this is the non-negative version. It has to be a false. And then we basically figure out what x and y are supposed to be. Once we figure out x and y, we can figure out the q. And the question was about t0. T0 was figured out like slightly earlier. By the time we get here, we already know that t0 is a 1. I kind of forgot about what the original question was. The original question was, how did we figure out t0, and that's how we got to t0. So it's a long line of reasoning, and it is so okay. So specific to this type of question in this particular exam, there is a little bit of Boolean algebra that you need to apply. Okay, in other words, you need to know that false and whatever is just false, and then when you have false or whatever, it's just the whatever. So those Boolean algebra stuff you kind of need to apply, because otherwise you will not be able to kind of deduce the values of all of the variables. Alrighty. Now, I can also argue that you don't need to know anything about Boolean algebra for those people who complain and go like, but Boolean algebra is not a prerequisite of this class. You cannot assume that we understand Boolean algebra. Fine, let's not look at it as Boolean algebra. Look at it as truth table, right? So what I mean is you look up the truth table of exclusive OR, and then you look up all the columns where the result is a 1, and the first thing is also a 1. Then you look it up and go like, okay, what can the second thing possibly be in order for the result to be a 1, and the first thing of the first operand to the operator is also a 1. So you can use that approach also, okay? And I'm pretty sure that we talked about the truth table in this class. So that's just another way to look at this, okay? It really boils down to the same thing. It's just, do you want to look at it from the symbolic perspective, like solving an algebra, or do you want to look at it from a more of a table lookup perspective? So you have all the truth tables, and then you just look up the truth tables and go like, okay, if this is a 1 and that is a 1, then we don't have a choice. This thing here has to be a 0. So they're equivalent. All those methods are equivalent. So do whatever you feel more comfortable with, but you still have to explain how you got to the answer. Are we good so far? All right. Okay. So let's move on to the other parts of the question. So this is just the first part. The second part is to figure out the values represented. Use the following bullets to enter your answer. Include calculations that show how you got the answers. Quoting from the number wheel is not an acceptable explanation. We never really got to the number wheel in this class. So I want to know the signed versus the unsigned, the unsigned versus the signed interpretation of Q, T, and D. Alright, so let's do that. Alright, so I don't ask about X and Y because they are too easy. Alright, so let's go ahead and take a look at Q, T, and D. Okay, so Q signed. Is it unsigned first? Yep, it is unsigned first. So now I'm going to use the notation that we have already introduced in this class, which is VU of Q, and we got 3 bits in this case. Alright, so what is it? It is 0 plus 2 plus 4, so it is just 4. Okay, so that's 1. And what about the signed interpretation of Q? This is supposed to be signed S here, and that's a negative 4. Okay, so to fully explain it, I can now say it is 0. We got 0 of 1, we got 0 of 2, and then we got 1 of 4, and it just adds up to 4. So in this case, we have 0 of 1, 0 of 2, and we have 1 of 4, but it is a subtraction in this case because it is a signed interpretation. There we go. And that's not an L, that's supposed to be a 1. There we go. So that's why the end result is just negative 4. Alright, so moving on to T. So T is a little bit longer, but it's okay. T actually has 4 bits. And with those 4 bits, it's 1 plus 1, 1 plus 2 plus 4. So we do have 1 of 1, we do have 1 of 2, and then we have 1 of 4. But then we have 0 of 8. So that means the answer is going to be 7 in this case. Alright, so Vincent, so you want us to show bit by bit addition? Yes, because because this is how you can show me that you actually understand how the value is represented. But once you have the format, once you have the template, you can just copy and paste it, because they all look the same. Alright, so now we move on to the signed interpretation. This is the unsigned, sorry. I forgot to change. I copied and paste, but I forgot to change. This is unsigned. And the next one is signed. And you can see how signed versus unsigned is really easy. It's really just, whether the highest power of the base is arithmetically negated or not. So in this case, even though it is negated, since we have 0 of those, it doesn't really impact the value. And then Taylor asked, why is 1 negative? Yeah, I took out the negation. Yes, I just fixed it. Alright, so 2 more of these. Let's see, the next 2 are for D. Alright, so I'm just going to be super lazy and copy the first 2 lines over here and then change references to Q to D. And then we just have to kind of put in the bits, right? So we have 1 of 1, 1 of 1, and then we have 1 of 2 and 1 of 2, and then we have 0 of 4, 0 of 4, and then we just have to adjust the end result here to be 3, and also 3 down here. And we got it. We have this part figured out. Alright, so that's the second part. And then there's also a third part. The third part is to compute T3 using the following steps. Okay, a bunch of people did not read the instruction and they just go like, oh, T3 is blah. No, I want you guys to show me exactly how you got to the T bit using the P and the G terms. So now we have to kind of answer those questions and say, what is the P term? So P in this case, so I'm going to use a multi-bit operation here, so it might look a little bit confusing. Yeah, it might look a little bit confusing. So P in this case is defined to be the negation of X, which is multi-bit, and then or Y, which is also multi-bit. So X, without looking at just individual bits, oh, you guys cannot see the answer, right? Yeah, there you go. So X is 101. So we have a negation of 101, and then we have an OR with 001. The bitwise NOT of 101 will give you 010 because we are flipping all the ones and the zeros around, and then we are ORing with 001, And since this is a multi-bit operation, the most significant bit is, oh, sorry, the most significant bit is ORed with the most significant bit to give me the result, the most significant bit of the result. So the answer is going to be 0, 1, 1 in this case. So that's how, oh, forgot to mention what this is. This is supposed to be P. And then G is the conjunction. So it's about the same, except we don't have a plus here, and instead we have a conjunction. So we can use a wedge as our conjunction. And with a conjunction, you need the same bit position to be both ones in order for the result to be a 1. So in this case, we end up with 0, 0, 0. Like so. And I should be typing G and not B. There we go. Alright, so that answers what is P and what is G. Oh, one more thing. I forgot to fix the definition. So I'm going to have to fix this one as the wedge. Okay, and. Alright, so that answers what is P and what is G as a multi-bit thing. So now we need to look up what is T3. So this is really just the application of the formula that we have figured out in class for borrow look ahead. So just kind of look it up, plug in the individual bits of P and G, and show me that you can figure out what T3 is supposed to be in that case. Yeah, that's fine. Vincent's notation is fine. Just without using the wedge, that's fine too. Or you can use an asterisk if you want to kind of really want to have an operator. So for the formula for P and G is not true. So for the formula for P and G is this not true. Alright, so I'm going to say one thing. Are we adding or are we subtracting? Yes. Yes, we are. So I think that answers the question. Yep. So this is why you have to be careful with what the question is asking. Are we adding or are we subtracting? Because both have P and G defined, but they're defined slightly differently. So you got to be careful about that one. Alright, so I am going to spell out the last portion of this question here. But I'm getting, let's see, what would be the best way to do it? Because I'm going to have to look it up. Yeah, why not? Just look it up. Alright, so these notes here is completely usable if you want to use it during the exam. It may not be that useful or may not be that effective if you're trying to look things up during the exam, unless you're the guy who wrote it in the first place. Since I was the guy who wrote it in the first place, it's a little bit easier for me to find that. And even so, I got it wrong. It is not here. It is in the binary addition part. Alright, fine. Let's go back to the binary addition part then. Alright, so I'm just using the search feature in my browser to look it up. And then I know exactly where it is supposed to be defined. It is down here. So K, which is T now, this is exactly how we should apply that. So I am just going to type it into the text channel. You cannot see it yet because I'm still typing. So T3 is G2 or P2G1 plus P2P1G0 plus P2P1P0K0. Whenever I say plus, I really meant or. Alright, so now that we got that done, we just have to substitute the actual values in this case, right? So G2 is a 0. P2 is also a 0. T1, that's not supposed to be T1. I mean, that's supposed to be G1 here. Alright, so G1 is a 0. Then we have P2, P1, G0. P2 is a 0, P1 is a 1, G0 is a 0, or P2, which is a 0, P1 is a 1, P0 is a 1, and then KT0, okay, fine, forgot to change that one. That is a 1. So when you have all of these things, it all compute to 0 or 0 or 0 or 0, which is a 0. So there you go. Alrighty. So does that match the end result? Yep. That does match, what is computed up here. So that T0 is a 0. It's double confirmed by another mean by using the borrowed look-ahead method. Alright, so that's one. That's one question, but once again, I'm using a lot of time to explain this. And in this case, okay, in this very specific case, the format of every single question is the same. So that means once you figure out the format of one question, the format of the next question is identical. So you can basically just reuse a good portion of it. The one portion that you cannot really reuse is the first part. But parts 2 and part 3, once you figure out the mechanical aspect of how to do the computation, it's just plugging in the different zeros and ones and you got it, okay? So it really is the first part that is important. Part 1 is the really, really difficult part. Or, some people think that is the case. Alright. So the NOT operator flips the sign for each bit. Wait. I'm not sure what that means. The NOT operator is logical negation. It flips a 0 to a 1, it flips a 1 to a 0, but it does not flip the sign. So I'm not really sure what that means. How I calculated P right here? This is a bitwise NOT. It is a bitwise NOT. So bitwise NOT applied to a multi-bit thing means I'm flipping each individual bit by itself. So if you want to use the tilde symbol, you can use the tilde symbol because it's a bitwise NOT. So bitwise NOT of 101 means I'm flipping the 1 into a 0, flipping the 0 into 1, and that's why we ended up with 010. It's just a multi-bit version of logical NOT. Alrighty. Alright, so I did have row prepared today, and I'm not going to let it go to waste. So we're gonna take row. Let's see. Today's row taking is. See, this is how I find today's date. Okay, 20220217 is today's date. Right there. Okay, so I'm gonna unhide it, and then I'll show you what the answer is supposed to be. All right, so go to edit, and there we go. We have the answer of Sudoku. That really should not be surprising, considering the format of the questions. Sort of. I mean, it's just that the rules have changed a little bit. Instead of using the usual arithmetic, calculations here, we're using Boolean, operators. But it's still based on constraints, right? So this is the key of learning how to do problem solving, because in the entire world, okay, there are only really so many ways to solve problems, or for the most part. And using applying constraints based on what you already know in terms of the rules and also the values that are given to you, that is how you solve these problems. You made a typo. How can you make a typo when you're copying and pasting? You're supposed to be copying and pasting. Just copy and paste. That's what I did. Okay, I don't trust myself to type. That's why I copied here and then pasted into the text channel. What is that telling you? I mean, you can trust yourself a little more than I trust myself, but I think the message is copy and paste is a more reliable way to do it. I think that's the point. All right, so that is one question, and we have Gannon typing. But once again, once you know how to get part two and part three, should be easy peasy. Okay, you just plug in different zeros and ones and get whatever result. Which most significant bit are we supposed to be looking for? All right. So it has to do with the definition of the L bit, right? And how is the L bit defined? Or better yet, okay, a better question is, where is it defined? Where is the L bit defined in the notes? Or did Tech completely forgot about the L bit and not tell you how the L bit is defined? I mean, it can only be one of those possibilities, right? So either it is there or it is not there. So the question is, where do you find all this stuff? Okay, because instead of answering the question directly, I'm going to help you guys find the answer yourselves. The sign bit of D, and where do we find it, right? So that's the important part, is how do you find all that stuff? So the obsoleted stuff, you can still read it, but I would just go for the the not obsoleted thing. So you go to the module, and then you look through this, and it explains, signed less than. It goes through a whole bunch of explanation. It goes through the definition of O, right? And then it goes through the definition of L. And then L depends on the sign bit of S, right? And S is defined up here. And S is by definition D of M minus 1. So now we need to look up what is M. But M is used throughout this entire discussion as the actual width of the subtraction. But the point is, okay, so Vincent is right. Okay, the point is we are looking at the difference. So right there, okay, so right there, it shows you the importance of reading the modules, right? It is in here, the definition is here. It is just a matter of reading it and capturing the definition in your own notes. Okay, just because it's here doesn't mean it's going to be easy to find during the exam. So you gotta make it easier for you, which means you extract all the definitions to one spot, so it's easy to find those definitions. Alrighty, getting back to the exam. So we only got let's see, 15 minutes left, and somebody asked me whether there's a lab tonight or not. By default, yes. So tonight we're going to have a lab, and we are going to do a little preview of what we're going to talk about on next Tuesday, and it has to do with exponents, powers, and stuff like that. So tonight's lab is kind of a warm up for those kinds of topics. All right, so let me go find one that is worth doing, because obviously I won't have enough time to do every single one, and it would be helpful to do one. Oh, this is a good one. I'm gonna do number 15, or let me see how number 1, 2, and 3 look. That one. Let's do this one. Question number 2. It just looks really, really funny. Yeah, I think 2 is a good one. This one, let's do 2. I like question number 2 a little better. All right, so this time I'm not going to spell out the explanation like this, but I will still explain it verbally. So here's question number 2. All right, so where do we start, right? That's always the question, is where do we start? Okay, we only have 4 bits known in this case. We have the overflow known, right? Here's our overflow, and then we have our most significant borrow bit also known. And the interesting thing is the overflow bit and the borrow bits, they are the most restricting equations. In other words, if the overflow is a 1, you have already locked down to the 3 bits, okay, x2, y2, and d2. You have locked those down to 2 possibilities, okay. There are only 2 combos that can be true. So that's definitely going to be useful. And then combining that with this t3 being a 1, I think we can figure out a lot of the bits, if not all of the bits, at bit position 2. So let's go ahead and start with that. All right, so we are now going to say, since O is, so I'll just be a little bit quick here. So O being a 1 implies x2 is a 1, y2 is a 0, d2 is also a 0, or x2 is a 0, y2 is a 1, and d2 is also a 1. So that, right off the bat, okay, we are now locking down, one of these two has to be true, okay, but only one of these two, right? So now we look at this and go like, what about t, the t bit, right? T3 is not x2, y2, or not x2 exclusive or with y2, and d2. Let's see. No, that's q, and then we have t2 over here. All right, and we know that is a 1. All right, so that is also going to be helpful. And it doesn't like exclusive or like this. We can use a fancy symbol in this case. Let's not do that notation. You probably want to spell out like 0, 1, 1 or 1, 0, 0 without the comma, okay? Because we are actually doing bitwise conjunction in this case. So we are saying not, we are saying false and true, or yeah. So yeah. Let's not shorthand to that. I think I understand what you mean by that, but let's just kind of spell it out a little bit like this. All right. Okay. So what can we do in this case? Because there are these 2 constraints, right? We know that we can have a 1, a 0 here, or we can have a 0, a 1, and a 1 over here. And the idea is we want to be able to lock down 1 and say, the other one is not possible. Okay, the other one is simply not possible. So what we do is we now just kind of plug it in and try out. Okay, so try. Let's try the first one. Okay, let's try x2 being 1, y2 being 0, and d2 being 0. Okay, and you basically want to show me that this is not possible, okay? Because otherwise you can have 2 things that are both possible, then it's really difficult to lock down the values. So we want to illustrate that this one is not possible. So in this case, okay, if this is the scenario, then q2 is going to be 1, which is fine. That is not a problem. But at the same time, no matter what t2 is, t3 has to be a 0 and conflicts with t3 equals to 1. All right, so this is the reasoning that you can use, is to say if x2 is a 1, y2 is a 0, and d2 is also a 0, that guarantees, just because of the definition of q, it guarantees that q2 has to be a 1. So now you have 1 minus 0, and then you have 1 minus whatever, right? But it doesn't matter what t2 is, because there's no way you can end up with a borrow. Because x2 minus y2 is 1 minus 0, does not give you a borrow of 1. q2 is going to be a 1, so no matter what t2 is going to be, it's not going to give you a borrow of 1. This is why we know that 1, 0, 0 cannot be the case. So now we try the other one. try x2 being 0, y2 being 1, and d2 being 1. Alright, so in this case, let's see how that's going to work out. Q2 is going to be a 0 because it's the exclusive OR between x and y. And right off the bat, okay, we know also T3 by the definition of T3. T3 is also going to be a 1 by calculation matching the given bit, right? Because it's also given to you that T3 is a 1. So far so good. Everything seems to be consistent. And then we also want to figure out what is what T2 is going to be, right? So we know that in this case D2 is going to be a 1. So D2 is a 1. Q2 is a 1 implies is a 0, is a 1. There we go. That both of those would imply T2 has to be a 1 as well. So everything works out. And then below said, shouldn't Q2 be a 1 since, yes, Q2 is a 1. Yes. Did I misspoke? Oh, right. Yes. Okay, very good. Thank you below. I did make a mistake, writing down the wrong answer here. So 0 minus 1 has a 1 over here with a borrow of 1, and then 1 minus 1 will end up, 1 minus, okay, where are we? We have 0, 1, 1. So T2 has to be a 0 now. T2 has to be a 0 because Q2 is a 1. And we want D2 to be a 1. So the only way to have 1 exclusive or with T2 to get a 1 is for T2 to be a 0. So this bit is going to be a 0. So that's basically the most difficult part of this question, this entire question. Once you figure this out, the rest is actually surprisingly easy. Alright, so let's go ahead and work out the rest. Yeah, we still got 5 more minutes. We can work on the rest. So now we know this bit here, the one that is highlighted, is a 0. So you look at this and go like, no way. We cannot figure out 4 unknowns by using only 2 knowns, for these bits over here. Well, it's surprising how this actually can work out, okay? Because we know there's no borrow. Okay, so let me go back to my notes here. Alright, so let's go back here, and now we're trying to figure out bit 1 of everything. So by this time we know T2 is a 0. We also know D1 is a 1. So now the question is, how do we go back and figure out X, Y, Q, and T in this case for column 1? So let's go ahead and check it out. Alright, so you have to basically go back to the equation, which is T2 is by definition not x1, y1, or not x1 exclusive or with y1. And then the whole thing ended with T1. And we know this equals to 0 because there's no borrow. T2 itself, the highlighted bit, is a 0. So we know that is a 0. And on top of that, we have one extra constraint, which is D1 is a 1. But D1 is really the exclusive OR between Q and T. So now we spell that out. So now we say, right, so we say X1 exclusive OR with Y1. And then take this whole thing and then exclusive that one more time with T1 is a 1. So these two are the constraints that we have. So now you have to look at these two and start to work on, how we can possibly make this happen, right? All right. So what we know, okay, from this one here, from this line here, in order for the result of a OR, this is just a regular OR, in order for the OR to be false, you need both sides to be false, right? So we now know that not x1 and y1 is false, and then we also know the negation of x1 exclusive or with y1, and then the whole thing ended with t1 is also false. All right, so given these two constraints, what else can we deduce? Now, knowing that D1 is a 1, we know that Q1 and T1 are different. So that's what we know is Q1 does not equal to T1. So those are the constraints. So at this point, you can plug in values. Okay, you can just kind of plug in values and try it out. We know that if you plug in, it cannot be 0, 1, okay? Because if you have x being 0 and y being 1, then you end up with a borrow. So that limits your choices, right? Because they can be the same, or you can have a situation where you have a 1 minus a 0. So those are the three possibilities here. If x and y are the same, then you end up with a 0 here, which in this case means the only way not to end up with a borrow here is for t to be a 0. But that will make it conflict with the D1 that is given to you because D1 is already a 1. So we know that Q and T cannot be the same, and the only way for Q and T to be different and yet not to give you a borrow for T2 is for Q1 to be a 1, T1 to be a 0. Okay, so you can basically use that to argue and say that Q1 has to be a 1 and T1 has to be a 0, so that D0 is a 1 and T2 is a 0. So that solves a pretty good chunk of it already, and knowing that Q1 has to be a 1, we get to the same argument. Okay, it's exactly the same argument, which is how can we make x and y so that the exclusive OR is a 1, but yet it does not give us a borrow of 1 for T2? Well, same argument. So in order to make Q1 being a 1, x1 cannot equal to y1, but if x1 is a 0 and y1 is a 1, then T2 is going to be a 1, which is conflicting with what we just figure out. So now we say so the only way is for x1 to be a 1 and x1 to be a 1, y1 to be a 0. So right there we solved all 4 bits in column 1. So it's going to be 1, 0, 1, 0 here. And then you will find that you are now in the same situation. So now you can basically go back and say, apply the same reasoning to column 0. Because the situation that we have is the borrow bit is a 0, and the difference bit is a 1, which is exactly the same situation that we had for the column for bit 1. So now you can just say, okay, repeat the same reasoning for bit 0, and then we backfill bit 0 here to be also 1, 0, 1, 0, and then the 1 is given here. So once we have all of these things figured out, the L bit is the exclusive OR between overflow and the sign bit. I cannot remember what a sign bit is supposed to be. Let me just look it up. Alright, so what is D2 in this case? So D2 is a 1. Alright, so D2 is a 1, overflow is a 1, 1 exclusive OR with 1 is a 0, so L is going to be a 0 in this case. So that basically solves the entire all the bits. And yes, I kind of cheated because I didn't write it down, okay? But the line of, well, I did write down quite a bit of the reasoning. The most important part of the reasoning I did write down here. Alrighty, so now we are moving on to the lab of tonight. So the important part is really getting back to the definition. You start with the definitions and the bits, the values that are already known to you. That is always how you get started with these kind of problem solving, is to rely on things that you already know. And then you just kind of plug it in and go like, okay, so we know this rule, and we know the values specific to this instance of applying this rule, and then you start with that and go like, okay, if I have an OR and the result of the OR is false, that means both sides have to be false. Now how do I make each side false? And or if you end up with an and the result of an and is true, then you know that both sides of the and has to be true. Then you ask the sub questions of how do I make each side true. So it's all based on those constraints. You just have to kind of nest the application of those constraints. All right, so let's get back to the lab. So I'm going to open up the lab for you guys tonight. And the lab is for floating point numbers. But you don't have to know anything about floating point numbers for this lab. Oh, that's okay. So if you have chosen computer science as your major, you probably should know, if nobody told you this, I'm going to tell you now. Computer science is one branch of mathematics. Now you tell me. Now you tell me. No, and I'm not even kidding. I'm actually saying, telling you the truth. Computer science is a branch of mathematics. It just doesn't look that way sometimes. All right, so double is the name of the key of the access key, and I'll give you guys some extra time tonight. I'm gonna make it 10 p.m. even. I don't think you guys will need it, but since we were just talking about math stuff here. I mean, we are not even talking about that kind of math, okay? We are talking about Boolean math here. Zeros and ones, literally zeros and ones, where everything can be interpreted using a truth table. I mean, once you can look up a table, it's like, it's not hard, okay? Once you can look things up using a table, it's not going to be that hard. I do want to kind of go over some of these questions, just so that you guys have an idea of what is involved in tonight's lab. All right, so we do talk about the scientific notation. That's the whole point, and it does explain. Okay, so the questions actually explain certain concepts. So you can also look up scientific notation on the internet, just so that you know more about the scientific notation. So the one thing I want to remind people is the lowercase e in the scientific notation is not natural log e to the power of something. That's one thing, okay? If I have to summarize all the warnings in one sentence, that is it, okay? So that e is not it's not the natural log. Okay, let me just make it very clear. I'm going to use a text editor to illustrate that concept here. All right, so if I give you a number, okay, which is just a notation, 1, 2, 3, E56, E is 4, 5. Okay, there we go. And I'm going to tap this over, because the line number can be interfering. This means we have a value of 123 times 10 to the power of 45. All right, so this is important. When you try to use a calculator to solve some of the values of this particular lab, it is calculator dependent. Okay, some calculators use a specific key to enter the exponent of 10, and other calculators would use a different key to do that. Whatever key you need to use, you need to look it up in your calculator's manual, because it depends on the calculator. Sharps and Casio and TI, they all have slightly different keys to do the same thing. All right, so, and I'm going to make it very clear that this is not 123 times natural log constant to the power of 45. Okay, this is the one thing. Okay, if there's one thing that people always make mistakes on, for this particular quiz, or lab, this is it. Okay, this E is not natural log constant. And I'm pretty sure somebody is going to do that anyway tonight because they are not listening right now. All right, so given that, I think the rest are pretty easy to do because you just have to remember your log stuff. So I'm going to give you that log stuff that you might have forgotten at this time. E is just a notation. It separates the coefficient part from the power of 10. This is the power of 10. Okay, so all right, so I'm gonna give you guys some of the log rules. Okay, so if x equals to y to the power of z, then log of x, whatever base you want to use is fine. Log of x is going to be z times the log of y. Okay, so that's one. There's another one that is kind of handy, which is if you want to use a specific base for the log, so you can say log n of x. So this is going to be the log of x, whatever log you want to use. Okay, so log m of x divided by, let's see, log m of n. There we go. So n is basically just a base, so it's m, because on your calculator, most calculators will give you two different logs. One log is log 10, the other log is the natural log. The natural log is going to be ln, and then the base 10 log is usually spelled as just log. But in these questions, sometimes you might need to use log of 2. So if you don't have a log of 2 on your calculator, it's no big deal, okay? Because this, in that case, this is log of 2, and then you can just use log of 10 and log of 10 of 2 to figure out what is the log 2 of a particular value that you need to figure out. And I think you need to know one more thing. The floor of x is the largest integer that is less than or equal to x. Yeah, because some of these you need to do some rounding, okay? But we're not going to do rounding. We're going to do a floor because we need to find the smallest integer that meets that requirement. All right, so I think these are some of the most important things that you need to remind yourself of, okay? Because all of these all of these are either coming from like math classes that you should have taken in high school, or it is already introduced in in this class. The concept of floor, I think it was introduced in this class. Yes, it is, because we talked about base conversion. So all of these things should be mentioned sometime already. It's just that for this particular lab, you kind of need all of these things together to figure out the solutions. All right, so I'm done with the lecture, and you guys can go ahead and get started. I'm going to go off and get something to eat, for maybe 10 minutes, and then I'll be back to answer the questions. I really don't think you guys will need all the way up to 10 p.m., but I'm just giving you up to 10 p.m. All right, so looks like we can probably stop the streaming and also the live share.